I'm pleased to introduce myself on this occasion. I'm Mercy Rufina, pursuing my PhD in Dr. Vinod Skaria's lab at CSIR IGIB. As we celebrate the 200th birth anniversary of Gregor Mendel this month, here we have Dr. Anurag Agrawal, the Dean of Biosciences and Health Research at Ashoka University, Delhi. I'm also very pleased to add that he was the former director of CSIR IGIB. He's a physician scientist who specializes in lung diseases and physiology. And also his visionary ideas on the future of biosciences in India has always been very, very enlightening and motivating for young researchers like me. So today he has joined us here to share his thoughts and opinions about the Mendelian discoveries, human genetics, and how it has contributed to modern science. So I welcome you here to the platform, sir. And I have, like I told before, like we have a set of few interesting questions for you, mainly based on genetics and how it has been contributing to science. So let me just start with asking a very brief introduction about your research interest or what kind of research your lab specially focuses on.
Thank you very much, Mercy. It's a pleasure to be here, seeing you again. So historically, my lab was a lung lab. So we focused on lung diseases, particularly asthma, which has very clear complex genetic inheritance. But of late, my focus has been on how to deploy emerging technologies, including genomics, in such a way that they are useful and guide us towards a desired health future. So at one level, been working on genetic leads for biology. Another level, trying to think of how genomic testing, revealing of results, interpretation, guidance in society can be used towards something that is beneficial as opposed to something that simply sets up another rat race.
Yeah, that's very, very interesting, sir. So this leads me to my next question. So being a research scientist, how do you think the Mendel's discoveries, or which was mostly pertaining to the human genetics, the fundamentals of human genetics, impact your research or any of the scientific things you are doing right now?
I think almost any of the people working in the fields, either of biology, either of genetics, either of experimental biology even, or towards public health, all of us are guided by the fundamental principles that Mendel described, that we have heritable traits, some good, some bad. And we need to recognize that this diversity that human beings have is carried by our genes, and they form a blueprint that we can read in some ways towards our benefit. So when I was an asthma researcher, I sometimes refer to this as a past tense because I think the current scope of what I do, the canvas, is much larger. It was very clear from twin studies that asthma is a very heritable disease. On the other hand, almost all the monogenic type of works, the jivas that were done, were barely able to describe a fraction of the total heritable disease. And what one realized was that perhaps asthma was simply a very loose word, because most diseases, if described in a very specific way, which are heritable, usually go back towards being linked to some kind of genetic variations. But a complex phenotype, like for example, simply bronchial hyperresponsiveness, can emerge from so many possibilities that even families that show very clear, powerful genetic heritability may not have exactly the same genetic defect as another family producing the same phenotype. So this allowed us to explore a wide variety of areas, the conviction of the fundamental correctness of the basic ideas of when you see very clear segregation in families of genetic inheritance versus the failure of simple things like jivas using loosely defined clinical words tells you not the genetics is bad. It tells you that the words that we use need a lot of improvement. So this guided me towards thinking about asthma and its various subphenotypes, and the realization that if I was in 1948 and used the word COPD, the COPD contains what is called COPD today, plus asthma, plus bronchiectasis, plus a variety of other post-tubercular bronchiectasis type of syndromes, which in those days were all relevant because there was only one treatment. All the diseases responded exactly the same way. So people just used one disease. When a new treatment for asthma came out. When a new treatment for tuberculosis came out, tuberculosis came out. So what we have reached, we are in this constant loop where we sometimes use clinical words which are vague as, the touchstone on which we do our genetics. So I think, and this is where it links to what I do currently, I think a questioning of our foundations in terms of how we describe disease, while we do comprehensive studies of genomes, relying upon the basic ideas provided by Mendel and others, and using data science to unravel this very, very complex mess is the way forward.
Yes, sir. Like I completely agree with that because as a young researcher myself, we all are fascinated towards the bigger picture of what we are researching, like what our research topic is concentrating on. But often at times we just don't dig back to the basics, which has led to this long way ahead. So this brings me to the next question, like I have for you. So, what is your say on the importance of studying genetics, either in school or college? Like the common awareness of the term human genetics in a general say, like what do you have to say about that?
To be honest, I can't even imagine modern biology without an understanding of genetics. I think it is that much of a foundational principle. And I think what we perhaps undersell ourselves is that we limit genetics to a simple study of the traits and their heritability, while not describing the dark matter part of what we do, linking it to actual genome organization and thinking and penetrance, interactions, the fact that things can be very, very distant on chromosomes in terms of how we sequence them, but could be right next to each other in terms of the actual topology of the organization. So, and of course, you don't want to teach all this complexity in school, but you must indicate the room for doubt. You must indicate the open challenges and the problems. What we err sometimes by doing is we teach biology like we teach physics. We teach it in terms of laws exactly the way Mendel said, without bringing in the nuances that I feel like biology has. So, like Newton's third law will remain exactly Newton's third law, the second law will remain exactly the second law. Perhaps at the level of quantum mechanics, things will change a little, but fundamentally, these are inviolate laws. Biological laws are a bit different, and we should teach it in such a way to spark curiosity as opposed to simple knowledge of laws. That's the only thing I would do a bit different in terms of the education. In terms of medicine, of course, it's absolutely critical. I think the time is not very far away when with dropping sequencing costs, it will be plausible to have at least a large fraction of people sequenced almost at birth. The costs of data storage and analysis might become greater than the cost of sequencing. At that point, doctors need to fully understand why they sequence, what to do with the sequence, what are the implications. And this, I think, needs to come into medical schools sooner rather than later, because this is not more than a decade away.
Yeah. So I completely agree with one of the points which you had stated regarding the educational part. So for this occasion, I've been talking to a few undergraduate students also, like why were they interested in biology and what made them choose this field. And one of the most common points I was getting from all of them was like, all of them told biology is a subject which involved a lot of memorization and memorizing certain terms and principles and everything. So like you said, it shouldn't be taught like physics or anything. So there should be a basic interest which should be provided to students at the very basic level so that they get to understand it more better and they'll be more inclined towards learning towards that path or something. So, sir, the next question for you is like, you being a medical researcher, and you have already stated those points in few of your responses before. So, how do you think moving forward or knowing more or going into more detail about the Mendelian genetics in each our research we are doing on our daily life, and how it would impact in deciding the health policies of a nation? Like you had stated some time back, like it's not far away. So if you could detail on that.
Sure. I mean, whenever I think of Mendelian genetics, Mendelian type of disorders in terms of medicine, it could be Tay-Sachs disease, could be anything. And you think of efforts made by communities to get rid of the deleterious, life-threatening genetic diseases from their gene pool, you pretty much have to start thinking of programs like Dor Yesharim or something like that, started in America, now in Israel, catering to the Jewish community everywhere. And for those who are not aware of it, the basic idea is that people who plan to get married would undergo testing. They would simply get a yes or no talking about genetic compatibility. The yes or no would only depend upon their carrying copies of similar recessive genes. So it's only catering to autosomal recessive disorders. A simple thing like this has really dropped the incidence of some of these diseases in a highly afflicted community. The program gives very little information regarding what disease you have, what you're carrying. You simply get a yes or no. This, of course, is a very simplistic version of what could be done in the future. It only caters, of course, to AR right now. It only caters to a certain set of disorders common to the Jewish community. But if we were to believe that this is a desirable future, which I personally think it is, there are many people who might disagree. I think it is a very good example of how classical Mendelian genetics applied through genetic testing in humans can benefit society. And of course, as we go forward from simple Mendelian disorders, you'll move to polygenic risk scores. And I would caution at this point in time, however, that polygenic risk scores may not necessarily be the best way to make very important decisions in life. But yes, life-threatening Mendelian simple diseases probably are. But again, that's an open question that I think a variety of people need to have input into.
Yeah, so I've heard about this in my own research also, like India being a consanguineous setting. This is something which will be like a very best example to state, like why do we need to implicate genetics more in our health policies and everything. And also, sir, right from the time I was doing my school or college to the time now, so there's been a lot of improvements in the bioscience research in the nation and how we are progressing forward towards betterment of health or quality of life, basically life science research. So my last question for the session is, like, what is that one thing, a future step or advancement which you feel would be like a huge step or a very motivating step in future pertaining to particularly to genetics or something?
Yeah, I mean, it's a great question. And I'm going to start by maybe enhancing what you said about the relevance for India. In my mind, it's really not about consanguinity. When we speak of consanguinity, we are speaking about blood relatives
Yes.
who have close genetic similarity marrying each other.
Yeah.
In India, it's an even deeper question.
Okay.
Even people who are not close relatives on the first look of things, so may not be cousins,
Yes.
may be genetically very similar to each other. And that is simply because of thousands of years of not marrying outside communities. If you look at the very nice work from CCMB by Dr. Thangaraj's group, you might remember something called identity by descent.
Yes, yes.
Which they look at lengths of chromosomes, lengths of segments of chromosomes identical from both your paternal and maternal chromosomes. So if long stretches of chromosomes on maternal and paternal are identical to each other, you could say your parents are related, even if it was not a consanguineous marriage.
Yeah.
What they found very importantly in many communities in India, many quite guessable actually when you look at marriage practices, were even more strongly linked genetics between their mother and father than even the Ashkenazi Jews on whom the Dor Yesharim started. So I always like to point out that if you belong to a community where you can attend weddings either from the bride side or the groom side quite easily, then the reality is whether you see consanguinity or not, genetically it's quite likely you have the same risks. And most communities, small communities, only marrying within each other, this simple line that I said, you go to the wedding and decide whether you're from the bride side or the groom side, it's a reality in India. So I think what we need going forward is an ethical framework in which these risks need to be communicated, measured, and acted upon. Clearly, you don't want to stigmatize communities.
Yeah.
Clearly, you do not want to create stress to people for something they have no power to change. But you want to provide people all the information that they need to make rational choices and go towards better health futures. This involves reading of genomes. This includes confidential interpretations of genomes to be communicated to the community by people trained in doing so. It requires proper ethical frameworks for the communications designed not only by doctors, but by the communities themselves. So it brings humanities. I would actually argue to you today that sciences is not just natural sciences, maths, physics, chemistry, biology, but also social sciences. And what I see as the way forward is a convergence of all the sciences, including social sciences, into questions like this that impact human lives, directions of communities, directions of nations, and global policy. And that is something I believe always belonged in the university system, hence my recent move. So you need to get many of these things together onto a common platform, and you just cannot have any one community within science trying to do it alone. So I think for India, that is the biggest challenge and way forward, because we currently have everything very compartmentalized. We have genomics institutes, we have medical schools, we have engineering colleges, we have universities that are separate from all these previous three, but do a little bit of them. We need to create more comprehensive systems. That's what I would say for India. I mean, I'm sure the same challenge that I'm seeing is true for many other parts of the world, may not be true for some others, but for India, given our relatedness in communities between parents, high risks of genetic diseases, a huge amount of ethical challenges and consequences of what we choose to do in terms of stigma in a relatively less informed population. I think a lot of work remains to be done.
Yeah. So on the same note, on whatever you have told, so I believe like the awareness should be given more. Like it should be whatever science being done in the lab should be taken to the public grounds, and we should make them aware of where we are heading to, so that they are also coping up with the journey.
Absolutely.
And they get to understand better like how are we going, what's the direction ahead. So
in the
yeah,
end,
sir,
it's
that
their
was
journey.
exactly.
In the end, it is their journey. And paternalism in medicine is not necessarily a good thing. It needs to be a shared decision making.
Exactly. That was a very, very valid point. So, yeah. So this was such a very, I had very less number of questions, and I made it very brief so that it should be of a greater reach. And I really believe it would be like very thought-provoking, and definitely many new ideas, different opinions and point of views you have stated here. So as we are in the end, I just want you to uh, share a few words or kind of a motivation pill for young researchers or students who are taken biology as their stream, or any science, like you have told, interdisciplinary is the key in the future. So any motivation pill or
Absolutely.
kind of encouragement?
No, great. I think the story of Mendel and thereafter the Mendelian genetics starts with the power of observation of the world around us. It involves contributions to science of the highest order by people who were not necessarily the most reputed or in the profession of science. It shows the power of an informed person interested in the world around them to contribute towards sciences. I think for all the young people or people of any age who are listening to this, I think that would be my message. Be an informed society, develop a scientific temper, and you will automatically end up contributing to the growth of science.
Yeah, thanks a lot. So you've always been encouraging, and you never stop to do so. So I really thank you for the time and this wonderful session, sharing your time with us and your thoughts. Thanks a lot.
My pleasure. Bye.
Bye.